All right, let's get started in your semester exam prep for the second semester exam. And this content is from Chapter 5. So the first four problems are dealing with operations of involving functions. So this first problem, we're going to be adding these two functions, f and g. So it literally looks like this. Here's the f function. And I'm going to add to that the g function. So what this really amounts to is combining like terms to come up with one single expression that represents the sum. So there aren't any other quadratic, that means squared terms, to go along with x squared. I do have a couple of linear terms, that means x to the first. So if I put 3x minus 5x together, that's negative 2x. And then I've got a constant plus 2. So there is the sum of those two functions, f and g. And number 2 is the difference. So I put the f function first, and then I subtract from it the g function. Subtraction can be a little tricky because we have to remember that we're subtracting both of these terms in this g function. So for that reason, I would recommend distributing negative 1 here to both of these. Negative 1 times 2, negative 1 times negative 5x. And then we're going to do the same thing we did in problem number 1. We're going to combine like terms. And 3x plus 5x is 8x. And then the constant is negative 2 or minus 2. There's your answer for number 2. Number 3 is the product of f and g. So for multiplying binomials, which is what we're doing here, we typically use a process called FOIL. First, outside, inside, last. And so my first two terms multiplied together would be 2x squared. The outside terms would be minus 5x to the third. The inside terms would be plus 6x. And then the last terms would be minus 15x squared. And then combining like terms, when you write this expression, standard form means you start with the highest exponent for x, and that would be the x to the third term. I'm going to put the two x squares together. 2x squared minus 15x squared is negative 13x squared. And then I've got this lone x to the first term plus 6x, and there's the answer for number 3. Number 4 is division of f and g. So here's the f function divided by the g function. If factoring is possible, I think that's always a good idea. I'll go ahead and do the factoring that's available for the numerator. Nothing is available from a factoring standpoint in the denominator, but sometimes by factoring we see opportunities to cancel matching factors. Now that's not true here. So on your answer key, if you're just looking at the answers, you probably see this as the answer, which is fine. Either one of these would be fine for an answer. I just think it's a good idea, if you can factor, to go ahead and do that, so then you'll see opportunities, if they exist, to do some canceling. As it is, nothing cancels. You can't factor you can't cancel terms. So either one of these would be okay for the division answer. Now we have to state restrictions for any of these that have restrictions. Number 4 is the only one that does, because a restriction means that we have to limit what the domain is to prevent situations like division by 0. And we do have that opportunity, or that possibility, if x is a certain number. So the way to determine what that number is make the denominator equal to 0 and then solve for x, and that will tell you how the domain has to be limited, or we use the word restricted. Okay, so I'm going to just solve for x, and I've determined that if x is 2/5, then that creates 0 in the denominator, division by 0. So in other words, I cannot let x be 2/5. And so the restriction on the domain can be stated like this. X could be any number in the real number system except for 2/5 in this particular problem. All right, so number 5 and 6, we're doing inputs into functions, and then we want to know what the output is. So I would recommend, I like to break these problems up, numbers 5 and 6. I like to rewrite them in this way. This shows that I'm going to be inputting 3 into both f and g. Now I'm going to be doing a little bit more with the f function. Once I input 3 and get that output, I'll then be multiplying that output by 2. So let's see what that looks like. If I input 3 into the f function, 2 times 3 is 6, 6 plus 3 is 9. So the f of 3 part, input 3, gives me an output of 9. And then in just a minute, I'm going to be multiplying that result by 2. Now over here, I'm just going to input 3 into the g function and then see what the output is. So if I let x be 3 in this g function, I get negative 9 minus 1, which is negative 10. So 2 times 9 is 18, and then subtracting negative 10 is really adding 10. So my answer for number 5 is 28. And then I'm going to rewrite number 6 in the same way. I'm going to find h of negative 2. I'm going to subtract from that inputting negative 2 into f, and then multiplying that result, that output, by 3. And then we'll be subtracting these two results. So h of negative 2, putting negative 2 in place of x and squaring it here would be 4. 4 plus 4 is 8. And then let's do f of negative 2. If I let x be negative 2 in the f function, that's negative 4 plus 3, which is negative 1. And so obviously 3 times negative 1 is negative 3, so we're going to be subtracting negative 3, which again, like we ran into in number 5, that's really adding. So 8 plus 3 is 11. 7 and 8 are problems that we call composites. And so the way this is written, I will first find g of negative 2. You're going to start finding the output for the function that's closest to the input. So if I input negative 2 into the g function, hopefully you can see I'm going to get an output of 8. Negative 2 squared is 4. 4 plus 4 is 8. And now this output is going to be used as an input into the f function. So I'm going to go to the f function and replace x with 8. That makes negative 16 minus 5, which is negative 21. So that would be my final answer for number 7. Number 8, I'm going to start by finding f of negative 2. So if I go to the f function and put negative 2 in place of x, that's 4. Negative 2 times negative 2 is positive 4, and then 4 minus 5 is negative 1. And now I'm going to do g of negative 1. Input negative 1 in for x and square it. You get positive 1 plus 4. And so my final answer for number 8 is 5. Okay, so there's really 3 answers for numbers 9 and 10. Find the inverse of each function. So the way I find the inverse of a function is I switch places with x and y first. And then my final step will be to solve this for y. So to solve for y, I'm going to need to add 1 first. And then you can either divide by 2 or multiply by a half. I'll show it as divide by 2. And then once you get this solved for y, I want you to show me the notation that means the inverse of f. So we started with f, and we came up with the inverse of f. So that would be like answer part 1, find the inverse. Now we're going to graph the function. Okay, so let's graph the line y equals 2x minus 1. So this should be familiar to us. We start at negative 1. This is y equals mx plus b. B stands for the y-intercept. So I'll start at -1, and then I count a slope of +2. And so I'll try to draw a straight line, but this would be the graph of the function f of x. And then we're supposed to graph the inverse. So you can either graph this. This is also y equals mx plus b. But you can also find the inverse graph by taking points off of the original function and then just switching the coordinates. So I'll show you what I mean by that. This point right here in black is -1, -3. So that means the inverse is going to contain -3, -1. This point in black is 0, -1. So the inverse will contain -1, 0. Well, if I switch the coordinates here for 1, 1, I don't get any difference. So red and black are going to intersect at that point. This black point is 2, 3, so for the inverse I'm going to plot 3, 2. So just switch the xy coordinates within each ordered pair on the function, and that will enable you to get the graph of the inverse. And so on your exam, if you run into this, you can just label your two graphs that way. Okay, let's do the inverse first. So switch x and y, and then solve for y. So that means I'm going to add 4 first. I'm going to do the square root of both sides. So that means I've got to do plus minus, and then I'm going to subtract 1 from both sides. And then once again, when you get to the point where you have solved for y, show me that you have found the inverse. And so you're just going to use that notation that means the inverse of f. Okay, so let's graph this parabola. I know it's got to be a parabola because it's squared, and I know the vertex, since I'm moving the parent left 1 and down 4, that's where the vertex is going. And then I can just do some other inputs to get other points, like input 0 into this. If you let x be 0, you get 1 minus 4, which is -3. And symmetry tells me that I've got another point that matches it on the other side of the AOS. And we'll do one more input. What if we let x be 1? So just come up here and replace x with 1. 1 plus 1 is 2. 2 squared is 4. 4 minus 4 is 0. So that's a point. So symmetry says this one is as well. And we'll just do a sketch of what this parabola looks like. So then we'll call this f of x. And so now we'll come up with the graph of the inverse just like we did over here. Just take ordered pairs from the black, like the vertex we said is -1, -4. So the inverse will contain -4, -1. You just switch places with those. This black point right here is -3, 0. So that means I'm going to plot 0, -3. This is 1, 0, so I'll plot 0, 1. Let's see, this point is -3, -3, so I'm sorry, -2, -3. -2, -3. See if I can erase that. I'm erasing everything. Okay. So I'm going to do -3, -2. And so you can kind of see this parabola is going to open to the right, and this represents the inverse. So pretty easy to find the graph of the inverse. Just take points off of the original and switch the coordinates within each set of ordered pairs. To determine whether two functions are inverses, we're going to do composites again, just like we did in a previous problem. And this is what we're trying to test. If we do these composite functions and we get the same result in each case, then we are going to say that yes, these are inverses. If we don't get x in both cases, then we would say no. All right, so let's just do it the way I have it here. I'm going to input the g function. The way this is written, the g function is going to replace x in the f function. And now distribute 3, so this would be x minus 9 plus 9. And sure enough, I got x when I did this composite, but I still haven't proven it yet because I've got to get x when I do it the other way. So if I input f into g, which is what I've done here, the f function gets placed into the g function as an input. Distribute 1/3, so that's x plus 3 minus 3. I got x in both cases, so my answer is yes, they are inverses. Okay, so here we're graphing the square root, the transformation of the square root parent. So the square root parent always looks like this. We can use these 4 points to represent the parent always. 0, 0, 1, 1, 4, 2, 9, 3. So I would just recommend that you put those on your paper. You don't have to actually connect them, just use them as references. And so we're going to, in order, we're going to do these 3 things to the parent. I'm going to multiply -2 times each y coordinate. So starting here with the origin point, 0 is the y coordinate. 0 times -2 is 0. And then this -2 means to go right 2. Okay, so I went right 2. And the +1 means to go up 1. So as I finish with each of those parent points, I'll just erase the black, and the red will end up being my answer. So 1, 1, after multiplying by -2, becomes 1, -2. And then I go right 2, up 1. And now that black point is done. Okay, so I'm here now, and so 4, 2, after multiplying by -2 becomes 4, -4, and then right 2, up 1. That one's done. 9, 3 becomes 9, -6. Right 2, up 1. And those red dots will be connected, and that will be my graph. And then we have to state the domain and range. The domain will be x's that are greater than or equal to 2. The range will be y's that are less than or equal to 1. Okay, let's try this one. Another transformation of the square root parent, so we'll just put those same dots here to start with. And this time we're multiplying the y coordinate of each of those 4 points by 3. Well, that doesn't do anything to the origin. 0 times 3 is still 0. So this says to go left 3 and up 1. So I'm going to go left 3, up 1. All right, so that one is done. All right, so for this point that's currently 1, 1, when you multiply it by 3, it's like it becomes 1, 3. And then we go left 3, up 1. Left 3, up 1. Okay, and that one is done. Okay, 4, 2 becomes 4, 6. Left 3, up 1. That one is done. And 9, 3 becomes 9, 9. Left 3, up 1. And there's the graph. of the transform parent. The domain will be x's that are greater than or equal to -3. The range will be y's that are greater than or equal to 1. All right, moving on to cube roots. So the cube root parent has these points that we reference: 0, 0, 1, 1, -1, -1, 8, 2, and -8, -2. But the process is the same. We don't have anything to multiply by on this one, so we're going to go left 2 and down 3 with each of those points. Left 2, down 3. Left 2, down 3. Left 2, down 3. And so the red dots represent, this is called a translation, a shift of the parent. Didn't have to do the domain and range on those. All right, so let me put my parent points back so we can see them. This time we're going to be multiplying the y by -3. We're going to go left 1 and we're going to go down 2. So we'll just do them in that order. So starting here with this far left point, multiplying by -3, well, the y coordinate currently is -2, so that turns it into -8, 6. Just multiply by the y. And then we're going to go left 1, down 2. And so that point far left is now that red dot. -1, -1 becomes -1, 3. And then we go left 1, down 2. Okay, multiplying -3 by this origin point doesn't affect it because 0 times -3 is 0. So then I go left 1, down 2. One 1 becomes 1, -3. Left 1, down 2. And then finally 8, 2 becomes 8, -6. Left 1, down 2. And so those red dots get connected. Missed that bottom one, but I think you see it. And that is my graph. Then we got a couple of square root equations to deal with. So make sure one's a cube root, number 17, but the bottom line is isolate the radical first. Make that your mission always, if it's not already done. So in this case, I'm going to have to subtract 5. And then I square both sides to get rid of the radical. And now I'm just going to solve for y like normal. And 54 divided by 4 is 27 over 2. Or you could have said 13 halves, 13 and a half. 13 halves, which was 6 and a half. Sorry. Okay, here I've got 2 steps. This is really the radical. It's a cube root. So I have to undo subtracting 6 by adding 6, and then I have to undo multiplying by 3, dividing 3. And now I can take care of the 1/3 or the cube root, just raise it to the 3rd power. And then subtract 5 from both sides. And we have our answer. Okay, I think we just have one more. For these inequalities, we have to be careful because x is going to be greater than or less than a particular number. which means we're going to have a whole range of numbers. You got to be careful that we don't put a number in for x that makes the square root of something negative, because that's not a real number answer. So the first thing you should do is identify what those numbers have to be for x that keep us away from an imaginary number. So x, when we plug in the number for x, it has to be either 0 or something positive. All right, so I subtracted 9 from both sides, and now I'm going to divide by 3 on both sides. So the numbers that my solution has to contain must be -3 or bigger. Okay, so now the second part of this is to just solve this as though it were an equation. Okay, so we got to isolate the radical, square both sides, subtract 9, divide by 3. Okay, so we got this number. We said x is 24, and then we said that our numbers for solutions have to be bigger than -3 or equal to -3. So what we're going to do to make sure we got our answer squared away, we got the right range of numbers, is just put these two numbers on a number line. You don't have to worry about testing anything over here because we've already established that the numbers have to be greater than or equal to -3. So what we want to know is, okay, does that mean the numbers will be between -3 and 24, or will they be numbers bigger than 24? So just pick numbers within each range. So an easy number to pick for between would be 0. That's a number in between. And so literally just go up to your original problem, input 0 in for x, and see if it gives you a true statement. Okay, so 3 times 0 is 0, 0 plus 9 is 9, and the square root of 9 is 3. All right, so when I do this math, I get 1 is less than 7, and that is true. So these work. Okay, well, let's just see if the numbers past 24 will work as well. So you can pick anything you want. I'll just go with 25. All right, so -2 plus, let's just go ahead and do 3 times 25 is 75, and 75 plus 9 is 84. Well, let's just think about this for a second. That is just a little bit more than 81, and we know what the square root of 81 is. That's 9. So this has to be a little bit bigger than 9. Let's just say 9.2, even if it's 9.1. Well, -2 plus 7 or plus 9.1 is about 7.1, which is not less than 7. So these do not work. And so we're going to stipulate our answer has to be between the numbers -3 and 24. And this is how we say between using inequalities. So the black represents the final answer. All right, I think we are done. So this takes care of the material from Chapter 5 that you're responsible for. I hope this helps. If you have any other questions, please let me know.